Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we observe that Olympia doesn't satisfy the conditions because O and the other vowels I and A are separated by some consonants. But we see from the example that Limpiod satisfies this condition. That's because we already have this string of vowels. There are only 3 vowels here, so once we have them adjacent, then we are good to go. Okay, so this we're going to denote the string by some sort of rectangle. Okay, so there are 2 aspects to this. So the position of the rectangle and also the composition of the rectangle. So in this case we have I, A, O. We could have other combinations. So on one hand, we can see this as having just 6 objects. That is L, Y, M, P, the rectangle, which always has to be in one piece, and D. So these are 6 objects. And we are okay with any arrangement of this, so long as the rectangle is always in one piece, right? And on the other hand, we have to look at the composition of the rectangle. So we have it has to be made up of I, A, and O, but in any order is going to be fine. So the different types of rectangles you could have, that's you could look at it like some kind of coloring. So for each of these string, it will be like a different color of a rectangle. So for different colors, we may have a different word altogether. So here we're going to have 6 objects we want to arrange. 3 objects we want to arrange to form our string. And these are independent in the sense that no matter how we arrange our objects, we can always arrange our 6 objects initially and then fill out the rectangle. So it doesn't the current arrangement of the 6 objects doesn't affect what we're going to fill in as a rectangle. It's still independent. So because of that, we can now use the multiplication rule. So we just find the number of ways we could do each of these and then multiply them together. For both of them, they are just permutations. So here we'll have permutations of 6 objects, which is just 6 factorial, by 3 objects, which is 3 factorial. So just solve this and we're done. Okay, so 6 factorial, that's so that's 1 times 2 times 3 times 4 times 5 times 6, and this is actually just 720 times 3 factorial, which is 1 times 2 times 3. So this portion here is 6. So multiply this together and we'll get 4,320. So A is the correct option. Alright, I hope you enjoy. Stay tuned for the next one.